So we're going to talk about beer hops and how those are used for many things. So, so hops are one of the four ingredients for beer, but they are one of the most expensive ingredients for a beer. So you can really increase the cost of a beer that you homebrew if you need lots of hops. Everything else is a lot cheaper, and so there's lots of variation you can do, but hops is definitely one that you'll see when you use hops and how you use them through the brewing process can make a big difference in their impact in the beer in terms of aroma and smell. So let's get to the big. So first we can say that hops have a big impact on beer's taste and smell or aroma. And so if you look at a hop, it has two main components. One is the resins. And the resins are water soluble. This will be important. It's how I remember. Soluble. And it's easy to remember that because the other component of hops are the oils, and these are water. I'm going to put insoluble in quotes. They have some solubility, but it's not nearly as much, and that will actually factor in to how they act in water. So there's a whole bunch of different types of resins and oils and hops. Each hop variety has a different amount. So, for example, in most hops, they contain about 2 to 15% of hop by mass, and these are called alpha acids. This is an alpha. So alpha acids make up about 2 to 15% of hops. They are in the boil. They are it's a process called isomerized, which basically means bond is flipped, which gives it actually very unique properties. So isomerized during the boil to form iso alpha acid. So this is showing that we've moved that bond, we've isomerized it, and I'll show you a picture here in a sec. These iso alpha acids are much more bitter. That's one thing, and they also help to preserve beer for longer. So they're also good for beer foam, good for beer foam, specifically the stability. There's a couple things that really kill beer foam. The preservation of beer, it's antimicrobial. And that's actually a really interesting story. So the beer that we brewed, and a beer that has a lot of hops in it, is a India Pale Ale. Now, pale ales were very popular in the when the colonial era was happening in Britain. And so the British sailors could not get their beers from Britain to India without them spoiling. And so what they found was that if you loaded up the beer with a ton of hops, and then in the boil they formed iso-alpha acids, that the beer could make it all the way to India. And so it was called an India Pale Ale for that reason, or IPA. So it was very functional, the reason why I did it, but it's actually the reason that the beer that we made, which was a New England IPA, in our recipe, no hops were added during the boil. Which meant, and this is something I actually asked my brewer friend about, because no hops are added during the boil, only about 7% of the the alpha acids were converted to isoalpha acids, and this is one of the main reasons why this style of beer is loathed by brewers, because it makes the beer very unstable. It only has a shelf life of about a month or less. But the public really liked it for the taste, because it turns out a lot of people don't like the bitter taste of IPAs. Anyway, that I thought was very interesting, that you don't necessarily need to have bittering hops or hops that are converted to isoalpha acids, but most do. So that's important. So resins particularly are useful for the bitterness. Alpha acids. So alpha acids themselves are not that bitter, where the alpha acids are much more bitter. So resins, again, are in charge of, or really responsible for the taste, the bitter taste, as well as some other properties. The oils, on the other hand, because they're water insoluble, they're going to come out of solution and you're going to smell them. And so there's been over 300, more than 300 compounds that are in this classification of oils. They are volatile, which means that they come out of solution pretty easily. And so they provide aromatic properties of a beer. And so the way that there are certain hops that are used for the resins, so they're bittering hops, and certain hops, like the recipe that I did, like Citra hops, Azteca hops, those hops are actually very aromatic, have lots of these compounds that people want to have in their beer smell, and so they are added to the end of the boil or after fermentation. After fermentation is called, that's an R. Let's back that up. It's called dry hopping. And that's where you basically add these hops to your fermented beer, and they just provide smell, no taste qualities at all. There's still a lot to be known about how these different hops provide smell. But there's so little known about how these compounds affect the beer smell or aroma, but it is assumed that there's some synergy. There's some synergistic effect that's taking place. So that it's a combination of beers that your nose is processing to come up with a smell. A lot of research has been going on into kind of figuring this out and trying to come up with a perfect hop combination to give a desired smell that someone's looking for in their beer. But there are definitely known beers like Citra hops, if you want a really citrusy beer, that can provide you these types of these smells. One example that I think is interesting is there is a hop oil. So this is a hop oil, one of the 300, named Myrcene. Myrcene is going to look like this. So this is where we can practice our line structures. So this little happy molecule is Myrcene. Myrcene gives you a very dank aroma to your beer. People who kind of want this very skunky, very dank smell, they're going to add lots of these Myrcene hops. So if we add these to the end of the boil or dry hop, then we get a beer that has this real skunky kind of dank smell. And so there's a brewing company in Colorado called Odell's Brewing Company, and so they basically brewed a beer that just maximized this particular compound. So they found all the hop varieties that had myrcene in the highest amount, and then they called the beer Mercenary, kind of a play on words. And they get that myrcene name in there, so kind of tricky. But basically, some breweries will say, we know this particular compound has this particular aromatic profile. Let's find all the hops that have it in the greatest concentration. And so a lot of food scientists are trying to figure out exactly match up smells and compounds, and then try to identify which types of hop varieties have the largest amount of these different compounds. So we're getting down to a very technical level. It's going from more of an art to a science in terms of hops. There's a lot of people trying to kind of craft this perfect beer from this from the actual chemical compounds versus is kind of just from experience and doing things. So I think that's pretty cool. So one problem with hops is that they can create off flavor. So this particular for resins, and I'll have the kind of a schematic of this, but resins, we know that they have alpha acids that during the boil we create a iso alpha acid. So these are not very bitter. These give us our bitter taste and our other properties, which we like. But they also have this problem where we have, if we have an iso alpha acid, okay, it's going to be in our beer, specifically in IPAs, and we have some, we'll do a different color. We got some UV light. That we can actually make some compounds from this. So we can basically get an isoalpha acid that makes a compound that comes off, and we make something called 3-MBT plus the isoalpha acid that is has a little part of it gone, so I put a little asterisk there. And this is the it's actually a very long name. We'll just do it because we like to impress people with big words. We have 3-methyl bute dash 2 ene dash E dash 1 thiol. And you can see why we actually have this here. So if you look at this, we have 3-MBT is where that name comes from. And the structure of this is not actually as intimidating as the name. And that is this is basically just showing you where the methyl group is. It has a number of carbons, and it has a thiol on one of the carbons. And this is what skunks will shoot out of their butt when they're scared. And so when if you've ever heard a beer is skunked, what that comes from is that this compound is being formed with the exposure to UV light. And this is why we have bottles that are brown. So when we have a bottle that is brown, the UV light is, there's different wavelengths of UV light, and most of it's reflected. The light that can get through is not the same energy that's needed to cleave a bond that causes this the formation of this 3-MBT. Beer bottles are colored, so they are brown or green, both of these colored glass, will filter the specific wavelength of UV light that causes the skunking of beer. Which I think is pretty cool that they do this, but you might be thinking, hey, what about beers that don't have the colors, so like a Corona? So this is actually a clear bottle, and so what's up with that? There's two things really. One is that not a lot of hops in Corona, so we actually make this problem not as bad. And the second is that the hops that they do use are synthetic, and these specific these are man-made hops, and these particular hops have removed the particular part of the isoalpha acids that get cleaved and then form this 3-MBT, so you don't have to worry about that. So the downside, so you don't get your skunking because you use a synthetic hop, but you do find other things like these will age in a way that it tastes more like cardboard. The other really interesting thing about 3-MBT is that our threshold to taste and specifically smell this is really, really low. And by low means it doesn't take a lot for us to be able to detect its presence. So the threshold, so this is how a lot of times we talk about our sensitivity is approximately 4 parts per trillion. So this is trillion. So that's so you could have 4 of these molecules in a trillion other molecules, and you could detect that. That's insane. You don't need very many molecules to undergo this reaction to notice that they're there. So you can actually, if you were to take a beer and just put it out in the sun for like a fresh IPA, so it's really important that you have a fresh beer with all these isoalpha acids which decay on their own. So you get a fresh IPA, put it out in the sunshine for like a day, and open it up and smell it. You can actually smell this molecule. Your nose is that sensitive to it. So it's actually one of the biggest things. And so this particular molecule, though it is now called 3-MBT, it used to be called light struck. And actually, if you go to some breweries, they only refer to it as a light struck compound and not by its appropriate scientific name. So that's very interesting. I think that you'll still see those in certain breweries. They use that terminology. So I think that's pretty interesting. So yeah, that's some hops. I'm gonna have a little worksheet, not a worksheet, but a handout that has what an isoalpha acid actually looks like, and the light struck process. You're not going to memorize that. I just want you to know that mainly isoalpha acids, not that bitter. You convert them to isoalpha acids. They are bitter. They have other properties, but the one thing that they can do is they can interact with light to make a very prominent off flavor. And to avoid that, we have bottles that are brown or green. And now we have cans. And cans are impervious to UV light. And so actually, there are a couple things. One is that they don't let any UV light pass through. So that's huge for this. They also are much lighter. And this is actually really important for breweries because the weight of empty containers and then the added weight of those containers with filled beer mean that they have more distribution costs that when you have a heavier container. So cans are much cheaper in the whole brewing process, and so more breweries are moving to cans. The only reason that cans weren't used is that initially when the craft brewing movement started, all of the macro brewing companies used cans. No one used glass bottles, and so it was a way for craft brewers to distinguish themselves from the macro breweries by using glass bottles. Sierra Nevada was one of the first. And there was a big fear that if you put craft beer into cans, people would confuse it with a macro brew. And there was one company called Dale's Pale Ale that was based out of Colorado, but now they're actually in Asheville, who had put all their beers in cans. It was really good. Their motto was "Because we can," and they kind of changed this model, and now almost every craft brewing company starts off with all their beers in cans, and maybe they put a couple fancy ones in bottles, but bottles are going away. Everything's moving to cans. It's cheaper, it's better for the environment, and it's better for the beer.